In my previous video on steam consumption, I said that it is important to determine quantity of exhaust steam used in heating juice and massacres in sugar factory to account for the cost of production. Today's video is directly related to that previous video, so some of the figures calculated in that steam consumption video will be used in this video. So if you have not watched that video, kindly watch it before you proceed to this video. In that video, I calculated quantity of exhaust steam in a sugar factory that does not have vapor bleeding. But today, I'll assume that the same factory has introduced vapor bleeding in their evaporation section. So I'll do calculation of that factory that has vapor bleeding system. At the end of the video, we'll see how vapor bleeding help factories economize exhaust steam. Before we start our calculation, let us see what vapor bleeding is. Vapor bleeding is a process in a multiple effect evaporator system where vapor produced in one evaporation body is divided into two portions, in which one portion is used to heat juice in the next evaporation body and another portion is used to heat materials in juice heaters or pan floor. Remember, vapor bleeding can be done from all evaporation bodies. For example, in our today's illustration, vapor from evaporator body 2 is divided into two, whereby part of it is taken to secondary heater to heat juice and another portion is taken to evaporator body 3 to heat materials in that evaporation body. And also, part of vapor produced from evaporator body 4 is taken to dynamic heater to heat juice and another portion of vapor produced from evaporator body 4 is taken to condenser to create vacuum. As I said, in today's case, we are going to calculate the quantity of steam used by the sugar factory that has quadruple multiple effect system with vapor bleeding. The table below has the figures that will be needed in our calculation. Remember, in juice treatment section, we are only going to calculate exhaust steam used by primary heaters, tertiary heaters, and clear juice heating vessel. Remember, we will not calculate the exhaust steam used in dynamic and secondary heaters because these two heaters did not use exhaust steam to heat juice, but they only used vapor from evaporation section to heat juice. The formula of calculating quantity of exhaust steam required for heating juice per hour in juice heaters is equals to quantity of juice in tons per hour times specific heat capacity of juice times temperature rise of juice divided by latent heat of the exhaust steam. Exhaust steam used in primary heaters is equals to quantity of juice per hour, and according to our table, the quantity of juice per hour in primary heaters is 130.23 times specific heat capacity of juice is 0.9 times temperature change, and according to our table, the initial temperature of juice is 45 and the final temperature is 75. So the temperature change will be 75 minus 45 will give us 30. So 130.23 times 0.9 times 30 divided by 531.73 will give us 6.61. That means the quantity of steam used per hour in primary heaters was 6.61. The quantity of steam used in tertiary heaters is equals to quantity of juice heated per hour, and according to our table, the quantity of juice in tertiary heaters is 131.79 times specific heat capacity of juice is 0.9 times temperature change. Remember, according to our table, the initial temperature of juice was 85 and after heating the temperature was 105. So the temperature change will be 20. So the quantity of heat will be 131.79 times 0.9 times 20 divided by 531.73. Remember, this 531.73 is the latent heat of the exhaust steam. This one will give us 4.46. That means 4.46 is the quantity of steam used to heat juice in tertiary heaters per hour. And according to our previous video, the exhaust steam used to heat juice in clear juice heating vessel is 3.22. So to get the total quantity of steam used in juice treatment section per hour, you will get 6.61 plus 4.46 plus 3.22. This one will give us 14.29 tons per hour. Since there was no vapor from evaporation section that was taken to pans and centrifugals, the exhaust steam used at evaporators, pans and centrifugals will be the same as that one that we got in the previous video. And in the previous video, we found out that the exhaust steam used at evaporators was 19.23. Exhaust steam used at pans was 24.72 and exhaust steam used at centrifugals was 6.14. So if you want to see how we got these values, kindly watch my previous video on steam consumption. So to calculate the total steam consumed in that factory, we will take 14.29, which is the exhaust steam used by juice heaters, plus 19.23, which is the exhaust steam used by evaporators, plus 24.72, which is the exhaust steam used by pans, plus 6.14, which is the exhaust steam used by centrifugals. This one will give us 64.38 tons per hour. In our previous video, we saw that the factory that does not have vapor bleeding, the exhaust steam needed to heat juice, massacutes, and sugar was 71.04 tons per hour. But for the system that has vapor bleeding, like for today's case, the exhaust steam used is 64.38 tons per hour. You can see that the factory that bleed vapor from two evaporation body save around 6.66 tons per hour as compared to the factory that does not have vapor bleeding.